the complexity of the instrument, it's a million miles away. Each command is critical and conservative, so you have to make sure that it was pointing at the right spot. And you have to make sure that the exposure is the right length. So there's that, as I'm waiting for that file to download, I'm thinking, did I do everything right? Did we as a team make all the calculations correct?
Danny, thank you so much for joining us on This Is Purdue. We've heard so much about you. You're a legend at Purdue.
Well, I'm grateful that you say that, but I'm just equally as happy to be here in front of you right now.
Tell us a little bit about your role at Purdue and kind of introduce yourself to our listeners and our viewers.
Sure. So I'm an assistant professor in the Department of Physics and Astronomy. I balance my responsibilities between maintaining a research program that utilizes astronomical facilities around the world, both on the ground and in space. And that goes along with the teaching responsibilities that I'm very happy to do. I teach a variety of undergraduate and graduate courses.
And you've had an interesting path to Purdue. You went to school in London, later to Dartmouth, to Harvard. What brought you to Purdue? Was it these big names like Neil Armstrong, or what led you here?
Well, that was part of the draw. At the time when I was considering my options, the decision was one that was dependent on myself and my wife. And it was really Purdue that stuck out the most. So Purdue showed their excitement in me coming as a researcher, but also in my wife, who brought a small business from Massachusetts. And I was really impressed, and no other institution came close to being able to accommodate both of our needs.
That's amazing. And going back even further, your interest in astronomy and the solar system, that started in elementary school, I read?
Yes.
Tell us about that.
Right. So, as far as I can remember, my love of astronomy and things in space all germinated with an assignment that I had in grade 2. And it was Mr. Wolaski who gave me an assignment to investigate the planets of the solar system. And I remember spending a lot of time, and that may have been just a couple hours, which is a lot for somebody in grade 2, but I think it was over weeks, where I went to the library and took out books, and I referred to encyclopedia, and I had a cover page and at least 1 or 2 pages of text per planet. And the memory that strikes with me most is making the cover pages, coloring them in with pencil crayon. I still have a sense like I was touching the planet. I had some kind of handle on the situation. So being fascinated by all the facts that I learned, it was that love that just kind of grew as time went on, and I found more and more opportunities to satiate that love.
Were there any other projects throughout your time, or were you really like, I need to focus and I want to eventually go in to study space and the solar system and everything?
Oh, I'm an astro nerd, so it followed me throughout my schooling. In high school, I joined an astronomy club. When I was in college, I was actually balancing at the time whether I would go into a more philosophical route of education, hence why I went to London School of Economics for a master's in philosophy and history of science. But anyway, I did have research opportunities then. And a lot of fun came out of that, like a discovery of new moons around Uranus, one of which I got to name.
Wow. So one of the most exciting things that you're working on right now is the James Webb Space Telescope. Tell us more about this telescope. It's the first of its kind, right? And how exciting that you're directly working with it, right?
I don't know how I can encapsulate that. I mean, right there behind us is a representation of the power behind the James Webb Space Telescope. So it is the largest, most powerful telescope we've ever sent into space. And somehow I am among the first group of scientists that get to use this for their research. And it becomes particularly relevant for me in my understanding of stars and their life cycles and how they come to dramatic ends, because it's sensitive to infrared light. And infrared light is sensitive to some of the material that we need to see in the exploded star to understand what happened, to tell its story.
So tell us why that research is important to us as humans on this planet.
Right. The big picture is that without this fundamental process in the universe of a star ending its life in this catastrophic implosion-explosion and ejecting its debris, seeding space, okay, with heavy elements, right? These are the raw materials that make life possible. The oxygen we breathe, okay, the iron in our blood, calcium in our teeth, okay? All these are thanks to the production of heavy elements from supernova explosions. Okay? And James Webb, again, is sensitive to the infrared light from which these stellar explosions emit and can be traced back to closest to where the explosion took place originally.
Take us back to the first time you saw the images from the James Webb Space Telescope. What were you feeling?
Wow. So there's two parts of that story. One is when I first saw any image from James Webb, and I had no special privilege like anybody else. Okay, I saw them with the public, and these were the first batch of images when the telescope was just feeling itself out. They're calibrating and aligning, right? It was a really rough trip up there, so they had to make sure that the mirrors were precisely aligned. In that first image, even though it was just of a bright star, it was spectacular in its clarity. And most importantly, one could download those data, and then you play with filters. You can stretch, you can make things highlight, and all of a sudden, you could see countless galaxies in the background. Okay? And for me, this was this transformational moment in the history of human civilization, right? We're so familiar with our naked eye looking up at the stars at night, okay, and knowing that the universe is filled with them. Okay? But now with James Webb, using infrared light, it was seeing galaxies everywhere. There is no empty sky with James Webb because there are galaxies, billions and billions everywhere. Okay? So that was when the first image came out. The other momentous time is when I saw the first data of my own program. Okay? Now, what we see behind us here is after a lot of work, a lot of processing, a lot of arrangement. So kind of like the panoramic filter on your phone, where you can't get everything in one shot, you have to pan it together, and there's some software that stitches the frames. We don't have that luxury. We had to do that all manually afterwards. So what I saw was just like a postage stamp area of the remnant. But when I saw it, two things. One, leading up to that moment was terror. Okay? Because unlike when I'm observing with a telescope at night, if I make a mistake, if I point in the wrong location, fine, I adjust and re-expose. Mm-hmm. Okay? But this is the complexity of the instrument. It's a million miles away. Each command is critical and conservative, so you have to make sure that it was pointed at the right spot. And you have to make sure that the exposure is the right length. So there's that, as I'm waiting for that file to download, I'm thinking, did I do everything right? Did we as a team make all the calculations correct? And then when it opened up, and I finally figured out where I was looking, because again, it's a small postage stamp amongst this enormous mosaic that we're making. That was the excitement, okay? That was the moment of, we did it, that this is working as anticipated. Okay? There's no way to properly describe that moment. Thankfully, it was captured by my wife. It actually came up on the 60 Minutes segment. People don't know this backstory, but it wasn't 60 Minutes there watching me at the time. That was my wife laughing at me, recording video to share with her friends. Like, we were supposed to go out Saturday morning, look what Dan's doing, right? And I'm getting all excited about the data, and that's what it ended up being. And footnote to that story, it was recorded on her phone, and it's at small scale. All of a sudden, when we watched that night on 60 Minutes, it's on the big screen. And you see all these details like some tortilla chip that had been left behind, and there is books and cores. We did not prepare this for international exposure.
And I heard your dog Might have made an appearance?
Wilbur, yeah, Wilbur is always there where something exciting is happening. And in this case, he could sense me getting excited,
Yeah.
and he associates that with his excitement, which is seeing some kind of rodent or animal running in the front yard. So that's why he was looking outside the window at that time.
That's amazing. What's something about the James Webb Telescope, or even this image here, that you wish more people knew about?
Right? Well, to put them together, I hope that I'm able to convey to people looking at this image of Cassay that we are getting a never-before-seen look at a stellar explosion. Now, what does that mean? What do we care? Okay? So I described earlier the story behind this. Okay? There was a star there, and it lived its life for millions of years. And then in the blink of an eye, in a second, it underwent this tremendous explosion, okay, and ejecting all the material, right, that will go on to form new stars and new planets, potentially with life. Okay? This is a fundamental process that I think as citizens of the universe, we all should understand. This image of Cassay captures that. It's kind of like a cosmic art, right, with a background story that I'm hoping to be able to convey to people.
And you talked about your team and, pointing this telescope in the right area and processing all this data. Tell us about your team and how you got involved in the first place with the James Webb Telescope.
Right, so in preparing for cycle 1 observation, so the telescope hadn't even launched yet. This was years in advance. Okay? There was call for scientists to develop proposals. And I felt like mapping Cassiopeia A, this supernova remnant, in this way, at this scale, needed the collaboration of dozens of scientists.
Right.
Okay? And to date, I think we have approximately 50 people from around the world that are all coming together. Okay? I keep looking at it because it draws me in. It's such a complex thing. It's messy. Okay? So the star itself is exploding. There's all this incredibly complex physics to model that. But that star had stuff around it, and it runs into that, and that influences the resulting debris field that we see. And it changes the dynamic. So one needs a interdisciplinary group made up of experts in many areas to be able to really piece together the entire story. And that's what I was looking for in combining what I call today the dream team behind our Cassiopeia A project with Webb.
And walk us through what's a day like with this dream team. Are you meeting weekly, monthly? Like, how does your work? I imagine it's all remote too.
Oh, well, we actually just had a meeting this morning. And it was at 9 a.m. to try and accommodate everybody's schedule. Unfortunately, California people had to wake up for 6 a.m.
Sure.
Right? But then in Seoul, Korea, we had people where it was, I think, 10 p.m. Okay? That's kind of part of the nature.
Right.
When we have general meetings associated with everybody, we find some sweet spot. Those happen on a monthly scale. But we do have weekly meetings, sometimes juxtaposed with even shorter time lapse between meetings to go over certain aspects. Okay? The problem with a large meeting is that there's so much content, there's not enough time for everybody to have equal say. So that is a kind of surface, bird's eye perspective of progress on the project, but then we zero in on the individual projects with smaller meetings.
What's the challenge that you've faced in your research, and how have you overcome it?
So these observations from Webb are the most fantastic, complex, rich, enormous of my career. And it has taken quite a bit for me to be able to find the right approach to handle that. Yes, I assembled a team, but being able to maintain enough oversight so that we're all communicating, right, while having enough ability to follow the projects independently takes a lot of bandwidth and time. And there was a bit of a transition period where that was all-consuming. But we're now like a lean, mean machine, and we're having regular status updates amongst us all.
What would happen if you weren't doing this research, if this dream team wasn't doing this research?
Well, if we at Purdue weren't leading this, I could easily name off dozens of other scientists at other institutions that would want to take the lead. This is the best example we have of a star that's exploded in our own galaxy, the Milky Way. Okay? This must be studied, and this is why it was selected as one of the first targets for Webb. It'd also be sad if Purdue didn't have it, because we wouldn't be able to brag that we're the only Indiana institution with, as being a principal investigator on a Webb program. So that's kind of cool.
Absolutely. And how is this research used in other institutions, even in NASA?
Right. So we have a number of people on our team from international institutions, including Princeton, including collaborators in Germany and Italy that run simulations of a collapsing star. Okay? And I mentioned again, and I don't want to scare people with the physics, but let's just say that it's very complex. And in fact, these simulations are run on the fastest supercomputers that the world knows. But because there are so many parameters, knobs you can tweak, things you can change to affect the outcome, they need some guidance and they need tests. So the work that we do with Cassiopeia A, and my related work, not explicitly with Webb, but previous work I've done on doing a three-dimensional reconstruction of the debris field, right? These provide vital tests and guidance for those simulations so they can use their time efficiently.
Okay. So it feels like the whole country knows that there's a Barbie movie coming out, right?
Yes, I'll be there.
So you and a team of researchers are also studying this. I'm not even sure what it is, but I want you to tell us about it because it's called Scary Barbie.
Right.
And was the name picked on purpose to go along with this Barbie mania? I need to know.
So, no. Crazy name for a crazy object.
Okay.
This was the result of a project we've been running here at Purdue for several years. And what we're doing is using sophisticated computer algorithms to be able to find unusual, interesting cosmic explosions, because they're happening all the time.
Okay.
In fact, in the universe, there is a supernova that happens about once every second. So if you listen for it, maybe you can hear a supernova explosion. You can't, but I always like to have that bit of dramatic eloquence. Anyway, so we have an algorithm that's picking things, and at some point, the system identified this anomaly, right? And something was different about it from the get-go. Okay? And because there are so many candidates for these cosmic explosions, they get names that identification numbers that are automatically generated, and they're very boring. This one was ZTF 20 ABRBEIE, which is like a mouthful, and that's not fun. But one night, one of our graduate students, Danielle Dickinson, it was late night, and she looked at it cockeyed. It's like, oh, it looks like Barbie. So the name stuck then. That's why we were calling it Barbie. I started calling it Scary Barbie when I fully appreciated just how energetic and explosive it was. So we were looking for supernovae. Okay? This event, once we identified the distance, and that's always one of the biggest hurdles in astronomy. I see something, but how far away it is. Okay? But at some point, we were able to measure the distance, and this made it not like a supernova explosion, but something that was 1,000 times more energetic than a supernova. Okay? And I don't know if these numbers really kind of reverberate with people, but for an astronomer, that scares me. Already, a supernova explosion is scary in energy. Think of the sun, okay? Over its entire lifetime, 10 billion years. You take that energy, you multiply it by 100, and that's what a supernova makes in 1 second. Okay? Now we have scary Barbie that's 1,000 times more energetic than that. Okay? Yeah, terrifying, scary. That's where the name came from. And once we follow the trail of evidence, right, ultimately we realize that the only mechanism we know that can produce something of that energy is the supermassive black hole we find at the centers of galaxies. Okay? So that people may be familiar with the mystique of a black hole, this
Right.
singularity from which not even light can escape. Well, there are very large ones at the centers of just about all galaxies, including the Milky Way. And they can be up to, in larger than 1 billion times the mass of the sun. Here's these large numbers again, right? But black holes are basically the most efficient method of taking matter, stuff. I don't want to think about us falling into a black hole, but taking matter and converting it into an energy. So that's why we ultimately favor the scenario that this wasn't a supernova explosion, but a supermassive black hole that was tearing apart a star that was close, falling in nearby.
Wow. I'm going to have to go back and like really process that.
I'll send you the paper. You can read
Yeah,
it.
yeah.
It's fine, yeah.
You know, you touched on it a little bit earlier, but how does Purdue's research influence the world's knowledge about space? We're a leading, university when it comes to how we talk about space, how your research is impacting the whole world, right?
Well, I'll say this. The astronomy part of our Department of Physics and Astronomy is relatively new, let's say in the last 20 years. But in that small amount of time, we've really punched above our weight class, let's say that, considering there are astro-intensive institutions that have been around for over a century.
Right.
And I attribute that to many things. One, we've always been an innovative school with a strong emphasis in computation. Okay? So that has driven a lot. So for my research, I've really depended on the computing resources that we have at Purdue. Along with that is the people. Okay? The Astro Group started by leveraging its expertise in high energy physics, okay? And then that expanded out to be aware of growing ability in data science, and branching out beyond that, balancing between those who are experimental and theoretical. And finally now with our latest hire, going from understanding evolution of galaxies and cosmology to understanding planets outside our own solar system.
And we're here, speaking of resources, we're here in the Envision Center right on Purdue's campus. Tell us about what goes on in here, the virtual reality component, and why your students, especially I've read, love that VR component. So tell us all about that.
Thank you. This is something I'm very passionate about. Shortly after arriving at Purdue, I sought out someplace on campus where I could do a better job of handling the data that I had.
Sure.
And here's a bit of advice for anybody at most any level. Whatever institution you're at, utilize the facilities that they have. And I knew that Purdue had strong resources in computation. And I found at some point, not too long afterwards, visualization as well. And that led me to contact people at the Envision Center, in particular George Takahashi. And things just came together nicely. I mentioned before my work with supernova remnants, the debris fields. My work beforehand had been very closely interested in understanding the three-dimensional arrangement. So when you look at an image, that of course is a projection. It's not a pancake on the sky. Okay, it has depth to it. So using the right observations, you can unpack that depth. But I always struggled on how to present it. Okay, I made animations that would rotate, and when I was really clever as a grad student, I made those 3D anaglyphs. You put the red-green glasses on,
Yeah.
and you can see it, right? So I went through that phase. But it was limited. It wasn't. I had no agency on the reconstruction to rotate it at angles that I wanted in real time. And that's where virtual reality has really played a pivotal role in making that desire, that dream become a reality. And so over several years, working with students and research techs here at the Envision Center, we've gone all out. And it's no longer limited to just Cassiopeia A, but we have a number of debris fields from which we can do comparative morphology, right? And we recognize that this is both a great research tool, where I can, in real time, rotate, compare morphologies, stick my head in, and have a look around, but a teaching platform as well. And for the past several years, through funding that's been provided by the National Science Foundation and internal grants that have been very grateful here at Purdue, we've made it available for students. And we've really explored all options. During COVID, we were able to rapidly adapt and loan out headsets so that students could put them on in their own dorms or wherever they may be. And we all encompass the same shared virtual environment. So it doesn't matter where they are,
right.
Okay? It would be like we were standing in front of each other and they could sketch out and I could walk them through a whole tutorial. So it's like a virtual field trip. Okay? There's no way, I don't think, that I'll be able to visit Cas A and bring people there. But we can set up a virtual environment where we can hover around and explore the remnant in all of its 3 dimensions.
Okay, that's awesome. I can tell you're really passionate about this topic and about teaching, though. Like, what's your favorite thing about teaching?
Well, equally satisfying as making a research discovery is sharing that discovery with other people. Okay? And that's what happens in the classroom.
Right.
I get to share not just my research, but knowledge that other people have found, and we can have this whole process of learning together. I think that is what makes teaching for me the most rewarding, the most fun, because that energy of learning something new, right? It can be tapped into and shared.
I certainly learned a lot of new things prepping for this interview, let me tell you. What would you say your most profound or favorite part of your research, most exciting part of your research has been so far?
Oh, well, okay. So the most exciting was being able to see the data come in for the first time, and there's video evidence to document that. I think amongst the most profound is when so here's another thing. People often think that, discovery is made like, oh, there's a moment when it just comes together.
Right,
okay?
right.
Often there's a lot of blood, sweat, and tears that incrementally build up till something, and it takes a little bit of a time for it to sink in, for it to really happen. Okay? So I think this image that's being portrayed, which is a variant of the one that was released publicly by NASA, this is probably among the most rewarding aspects of my career. Okay? It took a lot of work to make this image, okay? To put everything together, to balance the colors, okay? And then all the work that will follow from this. Okay? This is the wild ride, and it all started from this point when we were able to correct for things. I mean, a little bit of background story, drama behind the original image. Webb actually screwed up when it first took the mosaic. So I talked about panorama and stitching things together.
Yeah.
There was a problem in the software, and when it did its tiles, and I think there's about 15 of them, okay, it actually left gaps. There was holes in the remnant, and this freaked me out. Okay? Now, while the majority were covered, okay, there was still enough gaps. And so there was all this work to go and prepare a recovery mission to fill in the gaps. Okay? And it seems like, oh, you just point the telescope again. Well, it's a jam-packed schedule, so
Right.
fitting in additional observations. The spacecraft is constantly rotating, so you're worried about the orientation so that things look the same. There's just so much work that went into that. So now that we've finally done all that and the post-processing, that is the reward that will stick with me for the rest of my life.
That's exciting. How are Purdue students involved in your research directly? You talked about someone pointing out, wow, that looks like Barbie. Tell us a couple stories about how your students are involved with the research.
So students are involved with my research at all levels. And it may be from a first level student that just needs to learn about how do I open up an image, right? What am I looking at? What are the pixels representing? How can I measure the brightness of a star? And with time, they can become more sophisticated. And I'm very happy to say that the team that we have, made up of, at some point there was postdoc, graduate students and undergrads. There's a knowledge base that gets shared, and we help each other to train along the way. So I've had undergraduates that are able to lead papers published in scientific journals. Graduate students as well. So that scary Barbie paper, that was led by my current graduate student, Bhagya Subrayan, right? And I just feel like through having a research group that is supportive and that balances expertise, like the CASE Dream Team,
Yep.
we're able to really leverage that in times of need.
Okay, we want to get into the personal side of Danny, if that's okay with you.
Sure.
So you have a lot of interesting hobbies: music, comedy. You like to repurpose furniture, I've read. So tell us about the things that you do, when you're not extremely busy working on CASE and doing all your research and your teaching.
Well, okay, so you mentioned some of these things of my past, and I'll just touch on this a little bit. Yes, so music is a big part of my life, and there was a time where, I learned piano, I taught for many years, I learned some guitar, I was in a couple bands. That was a different Danny Milisavljevic. I had long hair, it was dyed black, I was in army fatigues, and we were really into that circa 90s industrial metal music and stuff. Anyway, so I've grown since then. I don't perform music like I do, but I still love opportunities when I can sit down in front of a real piano and just let the fingers do the walking. It's almost meditative in that regard. The DIY, the repurposing furniture, it started from a pragmatic need as we couldn't afford the really multi-$1,000 handcrafted furniture. So we started with some mold either from a tag sale or IKEA and, adding some trim to make it ours and such. So that occupies my time. But I will say I'm kind of also boring in that my research is also my hobby. There is never any substitute for handling a telescope individually. Okay? So even though there is, I'm at the cutting edge, the state of the art by using the James Webb Space Telescope. Right. It will never substitute the joy, the satisfaction that I get when I'm out myself at night using a telescope, watching the exposures come in real time, and just appreciate. It gets me all that closer to the universe.
And you talked about your wife, Lindsay, at the beginning of this, that West Lafayette's community welcomed her and her business. And it's a really cool, unique business, and I want you to tell our listeners about it.
Right. So the business is French Knot. It is a knitwear and gift company located in Lafayette. They make all sorts of things by working with artisans in Nepal. That includes mittens, hand warmers, scarves, and gloves, and like I said, many other gift items. And she sells to major retailers like Anthropologie, Free People, Sundance catalogs. I wouldn't normally know these brands, but because of Lindsay,
Yeah.
I do. She was on QVC many
wow.
times, right? And although she doesn't maintain a shop in town, you can purchase her products. There's a local boutique called Two Tulips, or you can go to FrenchKnot.com. And there's also the famous annual warehouse sale. Right?
Okay.
So, as I mentioned in the beginning, one of the draws to the greater Lafayette area was the support that she found from Purdue, where she was connected with faculty in consumer science and was able to get wonderful interns to help with running the business, expertise, small business owners in the area, connecting with Matchbox locally and the people there. So it's been amazing to watch her business thrive in that transition as we move from Massachusetts.
And you've been here since 2017? Is that right?
That's correct, yeah.
So what has this community meant to you, over the years, and with her business thriving and you doing all this exciting research? What does that Purdue and Lafayette community mean to you?
So if I could phrase it like this, looking back on these 6 years, I don't think that there'd be any other place that could reproduce the satisfaction and success that I found by moving here. And I mean that on multiple levels. One, we've talked about the research, my goodness, being able to use the James Webb Space Telescope and such, finding scary Barbie and other cosmic wonders, but also just personal wellness as far as being able, we moved in and day one, we had the Midwest greeting. People came with gifts and getting to know each other. I remember where we were living in Massachusetts, and I tried to introduce myself to the neighbor, and I think she thought I was some creep trying to, strike up a conversation. I was just trying to introduce myself. So that package, okay, of the abilities that Purdue brings along with the nurturing environment of the greater Lafayette area has been just a cocktail for success.
Do you have a favorite memory or two that stick out from your time here over the past 6 years?
So the memory that's coming to me immediately is my first time on campus, day one of the big job. And my wife dropped me off, and I looked around and I saw students going to class, and it was, I'm lost for words to describe it right now, but it was this overwhelming sense of, oh my goodness, I'm a part of this, right? I'm contributing to this enormous thing that is Purdue, right? That, along with the planes flying overhead, and I think more NASA T-shirts per capita than any other campus on the United States, right? That was like, wow, I've found home.
What role would you say Purdue has played in your life?
So I mentioned this already in the sense of there's no place that could reproduce the conditions that would have led to the satisfaction and success that I feel being here. I have just such a respect from the people, their professionalism, their compassion, their expertise, the willingness to take risks, to try something different. I struggled for a long time at other places to draw in interdisciplinary people to tackle a project. So for instance, this project with the Envision Center. I tried that for a long time, but it was only at Purdue that I was able to get traction on that. So what I really am happy about coming here to Purdue is the opportunity to explore all of my interests and really realize their full potential.
Yeah, absolutely. You know, we've heard throughout this whole interview all the persistence it took to get this image up, right? Have this image at your disposal. What does the word persistence mean to you?
Right. When you say persistence, there's a quotation from my father that comes to mind. And it's one that I say to my students all the time. It's, you do nothing, you know nothing. And this is a broken English from my father, who was an immigrant from the former Yugoslavia. But that's the translation that comes across, right? You do nothing, you know nothing. What does that mean? It means that unless you're out there doing it, okay, and you're building the muscle memory, you won't be able to really fulfill as far as you want. Okay? So I give the example of, I want to be a basketball player. So I'm going to read every book that was ever written about how to play basketball, and I'm learn all the strategies. Does that mean when I go on the court, I'm going to be sinking three-pointers from the get-go? No way! Absolutely not, right? I need to be on the court all the time, hours every day. Practice, 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 right? And that's the only way that I've really found true success, is to constantly being there doing it, right? They say half the job is showing up, and that's part of it, right? That regular follow-up, okay? And not to let some obstacle hold you from continuing, okay? So often when I hear people complain about some topic, about, oh, this research isn't going the way I'm going to do. Great, you've identified an obstacle. What are you going to do about it, right? That's the next step. Take action, okay? Persevere, show that persistence. That will get you across the obstacle.
I love that. Tell us about your experience with 60 Minutes and Scott Pelley. Were you nervous? What were
Oh
you
my
feeling?
gosh. That was, again, one of these terrifying, thrilling moments for me. I put it like this. The James Webb mission has thousands of scientists. Okay? And in that fairly brief 12-minute segment, they interviewed 6 people. And I was selected to be one of them. That's just, it continues to blow my mind to think about that. You couple that with my admiration for the show. I've watched it for decades, and especially Scott Pelley. The investigative journalism they do there is amazing. And now to be a part of that. Yeah? And I even have a deeper appreciation because it was great to be on there. My segment was about 1 minute, and a good portion of that was Wilbur. But even in that 1 minute, there were hours of phone conversations and dozens upon dozens of emails and text messages to make sure that every fact was correct. They wanted to convey the most accurate story possible. Now, they do so in broad strokes. They have to kind of filter it down, but they want to make sure that what they're saying is both accessible to the viewer and accurate.
Right. That's awesome.
And I mean, yes, again, going back to Scott Pelley, he is a hero. I have incredible respect. When they told me that it was him doing the interview, I really was beside myself. And so having an opportunity to sit face-to-face with him was something I will always remember.
Could he sense you were kind of nerding out, or were you playing it cool with him?
I know, as a matter of fact, that our interview was a little bit out of the ordinary, which is to say the camera crew and even the producer said, yeah, you don't normally get that kind of reaction, Scott. Because I said, oh, it's so great, I got a picture with him afterwards.
Yeah.
Yeah.
That's awesome. What would you say your next giant leap is? It can be personally or professionally when you look to the future.
So I really want every student that comes to campus to have an opportunity to use a telescope. And not the kind of rinky-dink kind, but something research level, pointed at an astronomical wonder. Because this institution is so founded on space exploration, as I mentioned, even me to this day, it never gets old when I set up a telescope and look through. Even the moon, which you think is boring. You see it so often in the night sky. No, whenever I see it under the magnification possible of a telescope, it gives a chill down my spine. And it's still, it provides rejuvenation of all the inspiration that drives me to carry out my research. And I think some of that should be sprinkled on every student when they come here.
I love that. Is there anything that I missed on any of your research? Any great Purdue stories that you'd like to share?
No, I think we hammered in on everything. Thank you very much for the opportunity to speak with you and share a bit of my story with your listeners.
Well, thanks for your time. It was a pleasure.
Wonderful. Thank you.
Thank you.